Okay, hello everybody. This would be our next topic for what chapter is this? Chapter 6, I think. Uniform flow in open channels. So under this chapter, we're going to discuss also this particular topic, cross section of greatest efficiency. Some books calls it most effective cross section, but most books ang tawag dito ay most efficient cross section or section of greatest efficiency. No? So the most efficient cross section of an open channel from a hydraulic standpoint, no, is the one which with a given slope, area, and roughness. Given slope, area, and roughness factor, that is Manning's coefficient, will have the maximum capacity. Okay, this section is the one having the smallest. So take note of this because we're going to, this is the principle behind this most efficient cross section. So this section is the one having the smallest wetted perimeter. Okay, wetted perimeter. And as can be seen from an examination of one of the open channel formulas, which usually is Manning's formula. There are usually practical objections to using cross sections of greatest efficiency, but the dimensions of such cross sections should be known and adhered to as closely as conditions appear to justify. So there are objections, of course, you know, because sometimes we are limited to the area by which we construct, for example, we call this a drainage canal. For example, the area intended for the canal is quite limited, so sometimes we do not adhere to this principle. For example, if you have a rectangular cross section, the cross section of greatest efficiency would be a rectangle having a base that is twice the depth. So medyo malawak yung kakainin niyang area if you're going to use the this particular section. So sometimes we are limited with the area, so sometimes we do not adhere to this principle. Okay, so one of the things that we need to look into is that this section, these sections may it be a rectangular section, trapezoidal, or any section. It should contain, it should have the smallest wetted perimeter, no, with constant discharge, constant area. So the cross section which has the highest or greatest efficiency, hydraulic efficiency, should have the smallest wetted perimeter. Okay, so wetted perimeter. Okay, so how do we identify or solve that particular section? For example, we have a rectangular section, so we're going to solve for um, the size or dimensions that would give us the section which has the greatest efficiency, hydraulic efficiency. Now I have already given in your modules the different uh, conditions, you know, for every section. Now, for rectangular section, the cross section which has the greatest hydraulic efficiency is when the base of the rectangle or the section is twice the depth. Ito. Okay, when the base of the rectangular section is twice the depth or the hydraulic radius is equal to d over 2. How did we arrive with this particular formula? So let's try to examine. Ito na lang sa module ilagay. This section. So sabi doon, the underlying principle is that we have the area is constant, the discharge is constant. But we're going to minimize the wetted perimeter. No? So for the area of a rectangular section, that is equivalent to base times the depth. And then the wetted perimeter is equal to b plus 2d. Okay. So with that, we know that B from this formula is equal to A over D, And B then, substituting the value of B in terms of D, it is A over D plus 2D. And since we are solving for the section which has the smallest perimeter or wetted perimeter, we're going to minimize the perimeter. And when we minimize, what do? Okay, we take the derivative, and equate it to 0. So the derivative of, we take the derivative of this particular equation. That would be, so A is constant. A is constant here. So A over D plus 2D. What's the derivative of this? We can put this dito sa my numerator. That is A times D raised to negative 1 and apply chain rule. Okay, that would be negative A all over D squared. So pag tinaas mo to dito, that is dito raised to negative 1 minus 1. So ipupunta natin yung constant na negative 1. That would make this term negative. And negative 1 minus 1 is equal to negative 2. And then ipunta ulit natin sa denominator. That would give us a term that is equivalent to negative A all over D squared plus 2. No, ito. Plus 2. With the equate natin sa 0, that should be equal to 0. So that would give us, ilagay natin sa left side ng equation, ilagay. That is A over D squared is equal to 2. Now take note, A is constant and that is actually equal to B times D. So we have B times D all over D squared is equal to 2. So yung isang D magka-cancel. So we're left with B over D is equal to 2. And then B is equal to 2D. So the cross section of greatest efficiency for rectangular sections, that is when the base is twice the depth. Okay. That is when the base is twice the depth of the section. Okay, that is for rectangular sections. Okay. So for the hydraulic radius R, so when the hydraulic radius is hydraulic radius is A all over the wetted perimeter, and it is also equal to B D all over B plus 2D. So we know that B is twice the depth. We divide it by B. B is twice the depth. So that is 2D plus 2D. Okay? We have 2D. And we simplify that. So the hydraulic radius is equal to, we have 2D squared all over 4D. And that would give us hydraulic radius that is equivalent to D all over 2. No? So that's how we derive for this particular, derive the formulas, for rectangular sections. Now the same is true also for trapezoidal sections. Now we derive it using the same principle we have used in the rectangular section. We also have derived using the same principle for triangular section. Okay, wait lang. Triangular section. Trapezoidal section, triangular sections. Okay. So for trapezoidal section, the section is most efficient when the top width is equal to the sum of the sides. Okay. When the top width, ito yung top width natin, x, sige lang, is equal to the sum of the sides, yung sides ng trapezoid natin. So y1 and y2 sides. So x is equal to y1 plus y2, and the hydraulic radius should be equal to d over 2. D over 2. Now for trapezoidal sections, the most efficient of all trapezoidal sections is the half hexagon. Regular half hexagon. So which means that yung sides nito, trapezoid natin, are equal. So if the base is x, that means the sides is also equivalent to x. And the angle of inclination relative to the horizontal inclination ng sides natin is equivalent to 60 degrees. Okay? So for trapezoidal sections, the most efficient is the regular half hexagon. Now for triangular sections naman, the most efficient is the V-notch, 90-degree V-notch. That means the central angle here is equivalent to 90 degrees, and the side slopes is one vertical, one horizontal. Now of all sections, the most efficient is the semi-circle. Yan yung most efficient of all sections. No. The most efficient is the semicircle, but we rarely observe or construct this particular section. Hindi natin ginagawa ito in actual because it would be, although it's the most efficient, it would be more costly, to construct this particular type of channel, no? Yung semicircular channel. Medyo mas mahirap gawan ng forms, no? Mas mahirap i-construct. Mahirap din gawan. Punta naman. Okay, so we rarely, I haven't seen one. Ganitong cross section. Now for circular sections, discharge is maximum when the depth is 93.8% of D, or it's 0.938 of the depth. No? Kapag puno kasi, hindi na siya considered na open channel, but it would be considered as pipe na, no? But when the discharge is maximum when the depth is 0.938 of the diameter of the circle, and the velocity is maximum when the depth is 0.82 of the diameter. So ganon. Okay. Okay, let's proceed to illustrative problems. Let's try to solve some problems here. So if the most efficient of all cross sections will be used, what shape and size of open channel would you recommend to carry 300 CFS? CFS is cubic feet per second with a velocity of 7 feet per second. Okay. So the most efficient of all sections is, I've mentioned this a while ago, that would be a semicircle. No? Semicircle, how would I draw a semicircle here? Let's try to draw a semicircle. So the recommendation would be a semicircle. Oh my goodness, did I just draw? My drawing is terrible. Just imagine this is a semicircle. Okay. Okay, we recommend a semicircle. What shape? Shape is semicircle. Size would be, so when we speak of size, we can pwedeng radius yan or diameter. No? So you can solve for the radius or the diameter of the semicircle. Let's say radius na lang ang compute natin to specify the size of the channel. So the discharge is 300 cubic feet per second, and the velocity is 7 feet per second. So we are to solve for the required radius of the semicircle. So if we are to solve for the radius, then we need to solve for the area. So yung area ng flow natin, so for the area to solve for the radius. No? Even if you want to solve for the diameter, you still have to solve for the area of the semicircle. So this all for the area of the semicircle. Very simple from our formula for discharge. That is equivalent to the product of the area and the velocity. So we know the discharge is 300 cubic feet per second. That is equal to area times the velocity, which is 7 feet per second. Okay, so we're left with area here. So the area is, what's the area here? Yeah. The area is 42.857. This is square feet. And then from that, we are to solve for the required radius of the open channel. So, ano yung area ng semicircle? That is pi r squared all over 2. So, area ng circle divided by 2. So, we have an area that's 42.857 square feet. So, it's equivalent to pi r squared all over 2. So, we're left with r in this particular equation. So the radius is 5.223 feet. So that would be the required radius for the channel. Okay. Okay, next, we solve the second problem, problem number 2. If the most efficient of all trapezoidal sections can be used, what shape and size of the open channel would you recommend to carry 300 CFS of water with a velocity of 7 feet per second? Compare resulting wetted perimeter with that of the first problem. So for sa problem 1, parehas sila, no? Parehas yung discharge and parehas yung velocity. So ang mag-iba lang would be the section, which is trapezoidal. So the most efficient of all trapezoidal section is the regular half regular hexagon, yeah. So ito yan. So dinawin ko na para hindi ko na i-drawing. Okay. Ito na. So but sa exam wala yan, wala ito. You have to draw it. Pero since I am terrible at drawing for illustration purposes, then I had to draw it in the computer. Okay, so we are to solve for the size. The size, so sa sizing ng trapezoid, you can solve for yung dimensions lang or yung length ng bawat side. You can solve that. No, that will determine the size. No, so we are to solve for the value of x in this particular problem. So we have solved for the area kanina. Sige, isolve ulit natin. So Q is equal to area times velocity. So the discharge is 300 cubic feet per second. That's equivalent to area times the velocity, 7 feet per second. So the area is 42.86 square feet. Again, from that, we're going to solve for the required size of the trapezoidal channel, which is would be the value of x, ano? Yung x, yung length ng bawat side natin. So we know that the area of a trapezoid is equal to yung upper base natin, x plus, so yung buong lower base plus yung upper base natin, ito, that is 2x all over 2 times yung depth natin. This would be the depth. The depth is, so this is given this hypotenuse of the right triangle, that is the sine of di tuloy x sine of 60, so opposite side siya. So that is x sine of 60 degrees. Okay? Okay. Bakit 2x pala ito? Itong upper base natin. Baka saan yung saan kinuha ni Sir yung 2x. Although meron na dun sa may I think na percent ko ata yun sa sa figure. Hindi pala. So if this is actually this side of the triangle, ano ba tong side ng triangle na yan? So this side of the triangle is parehas lang sila dito. This right triangle. So this side is x cosine. So adjacent side yan. So x cosine of 60 and cosine 60 is half, no? Which means this is x over 2 and this is also x over 2. So x over 2. So we know that this is x, no? This is the lower base is x. So 2x plus twice of x over 2, that is x plus 2x plus twice of x over 2 is that would be 2x. The upper base would be equivalent to 2x. Okay? That's doon ang galing yun. So the area, so since we know the area, we can solve for the value of x here. So this is 42.86. We have x plus 2x all over 2. We multiply it by x sine of 60 degrees. So that the size of the trapezoid x is equal to 5.74 feet. No? So yun yung sizing natin. So dapat ganyan yung length ng bawat side ng trapezoid. Next, we are to compare also. Compare natin yung wetted perimeter ng number 2. Compare natin sa wetted perimeter sa number 1. So first, we need to solve for the wetted perimeter of the semicircle. Let's say PS. So from the... sa kabila na lang. So PS, yung wetted perimeter ng semicircle. Take note, ano yung radius kanina? The radius is 5.223. So we are to solve for this perimeter. So how do we solve for the wetted perimeter? That is the circumference of the circle divided by 2. Ano? So that would be, ano yung circumference ng circle? That is pi d or 2 pi r. So, 2 pi r divided by 2, that would give us the perimeter of the semicircle, which is pi r. No? So, that is pi times the value of r. The radius kanina is 5.223. So, 5.223. So the wetted perimeter of the semicircle is 16.4. Okay. And then the wetted perimeter of the trapezoid, let's say P sub T, that is ito, itong side na yan, that is 3x. So the wetted perimeter is, we have 3 times 5.74. So the wetted perimeter is 17.22 feet. So you compare the two. No? Compare mo yung dalawa. Wetted perimeter. They have the same area of flow, the same discharge, the same velocity, but they have different wetted perimeters. Okay. So if you want to construct, for example, if you want to construct an open channel, no, of course you would prefer this one kasi that would be less costly in terms of the materials that would be used in terms of cost, no. less expensive, no, yung especially if you're going to construct a channel that is kilometro yung channel mo that traverse kilometers of farmlands, so that kapag irrigation, no, this would be in terms of materials, cost will be more preferred than this one kasi mas mahaba yung kailangan mong construct na perimeter. But of course, you have to consider other factors also, no? For example, dito, since semicircle ito, medyo mas mahirap siya construct. That would be more difficult in terms of that would be more expensive in terms of labor because you have to that might take you more time in constructing in terms of the forms that would be used. Sa trapezoid naman, medyo mas madali siguro i-construct yung trapezoid. So, you can compare yun na lang in terms of cost, labor cost, materials cost, no? Okay? So, ito yung defense. So, the most efficient, of course, is the semicircle. Trapezoid, ito yung sa trapezoid. Mas malaki ang kailangan mong perimeter compared dun sa may semicircle. Okay? That's it. So, we'll solve the other problems in a separate video na lang.